We now talk about capacitors in an AC circuit. So you consider an AC circuit like this right here. So this is an AC circuit and you have applied the voltage V and there is a capacitor right here. So this applied voltage is V. So this is essentially instantaneous voltage. So then by Kirchhoff loop rule, we have V minus Q by C is equal to 0. So you now plug in, instead of V, you plug in V is equal to Vm sine of omega t. This V subscript m is the maximum voltage. So now this equation becomes V of m sine of omega t. This is equal to Q by C. So this sine of omega t. So you multiply both sides by C and you get Q is equal to C times Vm sine of omega t. Now current, you know, is equal to charge flowing per unit time. So current is dq by dt. This we have also explained in previous lectures. So you just differentiate this expression now. C and Vm are constant, they come out, and you know that d by dt of sine of omega t, this is nothing but omega times cos of omega t. So this is how you get omega times cos of omega t here. So we rearrange this. You get I is equal to omega c Vm. So this is the maximum value of the current. We denote it by I subscript m. And we rewrite cos of omega t as sine of omega t plus pi by 2. So this is nothing but cos of omega t. So notice the voltage here has sine of omega t. So notice you have sine of omega t here and you have omega t plus pi by 2 here. So sine here and sine here. So you can see now the current leads the voltage by 90 degrees. So we can see this in the diagram here. The voltage is given in red. So this is instantaneous voltage. So this is the maximum value of the voltage. And the graph in blue gives you the current. And this is the maximum value of the current. So current is leading voltage by 90 degrees. So this is more clear in a phasor diagram. So in the phasor diagram you can see this red portion is the voltage. So length of this red vector is the maximum value. So say this makes an angle omega t with the x-axis, and this blue vector is the current and the length of this vector is the maximum value of the current. So you can see that the blue vector is leading the red vector by 90 degrees. So in the phasor diagram you always go anti-clockwise. So now we talk about capacitive reactance. So current achieves its maximum value. So you can see in this equation you have the current here and this is C Vm omega cos of omega t. So maximum value of current is when this cos term, so this cos term is plus or minus 1. So you're taking the maximum value in an absolute sense. So forget about the sign here. So the maximum value of the current essentially is omega C Vm. So the maximum value of current is omega C Vm. We rearrange this as Vm divided by 1 over omega c. And we call this 1 over omega c as xc. And this xc is called capacitive reactance. And this Vm is nothing but maximum voltage. Now you can divide both sides by root 2. So Im by root 2, this is equal to Vm by root 2 divided by xc. So this immediately gives you that Irms is equal to Vrms by xc. So this xc is called capacitive reactance. The unit is ohms. Notice that capacitive reactance decreases as the frequency increases. So omega is 2 pi f. So as the frequency increases, omega increases, and since xc is equal to 1 divided by omega c, as omega increases, xc decreases. So let us give an example. So say there is a capacitor of 15 microfarad, that is 15 into 10 to the power of minus 6 Faraday, connected to a 220 volt 50 hertz source. So the capacitive reactance Xc is given as 1 divided by omega C. Now what is omega? Omega is 2 pi f times the capacitance. So you get 1 divided by 2 pi 50 times 15 into 10 to the power of minus 6. So this comes out to be 212 ohms. So the RMS current is given as, so I is equal to V over XC. So IRMS is VRMS over XC. So since we are just given a supply and not told it is maximum, we assume it is RMS. So if no one tells us precisely that this is maximum voltage, we always assume it is RMS. So you have 220 divided by 212. So the RMS current you get is 1.04 ampere. So if you want to find the maximum current, you multiply 1.04 by √2.